Hey kids, Flexing Teacher Weber here. I hope you're having a good day. In math, we have been studying ratios and looking at equivalent ratios. And what we're going to do now is we're going to focus on problem solving with equivalent ratios using proportional reasoning. So when we have two or more equivalent ratios, this is called a proportion. For example, 4 to 5 equals 8 to 10 equals 12 to 15. That's a proportional reasoning. That's an equivalent ratio, and that's a proportion. We can use proportional reasoning in real-life situations like baking, where we have to increase or decrease the size of a recipe. Navigating, if we have to look at a map, and the scale of a map will sometimes have like 1 centimeter on the map is equal to 100 kilometers in real life. So we can use proportional reason in navigating. And in banking, when we're talking about exchange rates, comparing what the Canadian dollar is worth to the American dollar and so on. So those are some examples we'll look at of proportional reasoning. Let's look at a couple of problems that involve baking and cooking. So for each problem, we're going to identify the unknown, we're going to make a comparison, we're going to write a proportion, and we're going to solve. So this problem says 1.5 cups of water is needed for every cup of rice when making jasmine rice. How much water do you need to make 4 cups of rice? Well, the first thing we want to do is identify the unknown. And identify the unknown is the water. You can see that in the question right here. So we're going to write let x will be a variable that represents our unknown. Let x equal the water. Now we're going to make a comparison. The comparison I want to make is in words. We want to know what we're comparing. And in this problem, we're comparing water and rice. So let's compare water to rice. Now, we're going to try to make a proportion or two equivalent ratios that compare water and rice. Well, in the problem, it says 1.5 cups of water. So 1.5 cups of water is needed for every cup of rice. Might be better if that said every 1 cup of rice. Okay, so 1.5 cups of water is needed for every cup of rice. That's our first ratio. Now our second ratio is going to include the unknown. It's going to include the variable. We want to know water. Since we said water is the top of our ratio, let's put x on top. So we want to know how much water is needed for 4 cups of rice. So the second part of the ratio is x over 4. And this thing right here is called a proportion, 2 equivalent ratios. Now we're going to solve that. We ask ourselves, to go from 1 to 4, are we getting larger or smaller? Well, we're getting larger, so we're going to multiply, and we're going to multiply by 4. Since the ratios are equivalent, we'll do the same thing to the top. And 1.5 times 4 is 6. So x is going to be equal to 6, and we should label what that is. That is 6 cups of water. That's called creating a proportion to solve a problem. So we identified the unknown, we wrote what the comparison was, we created a proportion with that unknown, and then we solved it. So far in class, we have just been focusing on solving these. Now we're creating them in word problems. Let's do another one. A salad dressing recipe calls for 125 milliliters of olive oil and 50 milliliters of vinegar. How much oil do you need for 300 milliliters of vinegar? Well, look at the problem. It says how much oil. So let x equal olive oil. Oh, my pen's not working well. Olive oil. Try to keep these really simple. We don't want to write too much. The idea is to keep it simple. Okay, well, what are we comparing in this problem? Well, we're comparing oil and vinegar. So that's our comparison. Oil to vinegar. Okay, now let's make a ratio that compares oil to vinegar. I see in the problem 125 milliliters of olive oil is needed for 50 milliliters of vinegar. So 125 over 50 equals, let's make another ratio with the unknown. The unknown is olive oil. We've said olive oil is on top, so we'll put X on top, and we want to know how much olive oil we'll need for 300 milliliters of vinegar. There's our proportion. To solve it, we ask ourselves, what are we doing to 50 to get 300? Are we getting larger or smaller? Well, since we're getting larger, we're going to multiply, and we'll multiply 50 by 6 to get 100. You'll do the same thing to the top. Okay, I know 100 times 6 is 600. 25 times 4 is another 100 for 700. And then 25 times 2 is another 50 for 750. So X is equal to 750 milliliters of olive oil. Now, I got to tell you, there better be a lot of lettuce and stuff in that salad, or this is just going to be an oily mess. That's a lot of oil. This is going to hopefully be a salad for like an army of people, because it better be pretty big, else it's going to be pretty oily. Let's do another one. You've probably seen these before. An ad said 2 out of every 3 dentists recommend a certain toothbrush. If 42 dentists recommend the toothbrush, how many were surveyed? Okay, so this one a little bit trickier to maybe identify the unknown in the comparison. So to identify the unknown, it says 42 dentists recommend the toothbrush. How many were surveyed? So let X equal number, not hashtag, but number of dentists surveyed. Okay, well, what are we comparing in this problem? Well, we're comparing dentists who recommend the toothbrush to dentists surveyed. So let's see if we can shorten that. D, recommend brush, just to shorten it, over D, surveyed. So maybe a little bit trickier to get the comparison out of this one. Okay, well, do we have a ratio in this problem that compares dentists who recommend the toothbrush to dentists surveyed? Well, I see 2 out of every 3 dentists recommend the toothbrush. So the 2 is the recommending out of every 3 surveyed. Now be careful here. It says, for the second ratio, 42 dentists recommend the toothbrush. Look where we've put recommend. Recommend is on top. So in this one, we don't put the X on top. The 42 goes on top. And then we said our unknown was number of dentists surveyed. So the unknown is X. The X goes on the bottom on this one. You can't just always put the X on top. It depends how you've created the ratio. Okay. To go from 2 to 42, we multiply, and we multiply by 21. So we'll do the same thing to the bottom. 3 times 21 means X is equal to 63 dentists were surveyed. All right, so proportional reasoning. Let's do 1 or 2 more. This one says 4 out of every 5 students in grade 8 prefer to play volleyball over any other sport. If there are 90 students in grade 8, how many students prefer to play volleyball? Well, start off identifying the unknown. How many students prefer to play volleyball? Let X equal students who prefer, and I'll shorten up volleyball for VB. Okay. Now the comparison. We're comparing students who prefer volleyball to total students in grade 8. So for the comparison, grade 8s would prefer VB over all grade 8s. Okay, well, let's use numbers now. It says 4 out of 5 students in grade 8 prefer volleyball. So 4 students prefer volleyball out of every 5. Okay, our second ratio has to have our unknown. The unknown is students who prefer volleyball. That's the top ratio, so that goes on top. And then it says there are 90 students in grade 8, so X over 90. Okay, to solve this now, to go from 5 to 90, I'm getting larger, so I'm multiplying. What do I multiply by? Well, I know 5 times 10 is 50. I know 5 times 12 is 60. 5 times 14 would be 70. 5 times 16 would be 80. So 5 times 18 would be 90. And then that means we do 4 times 18. Well, I knew 4 times 10 is 40, and 4 times 8 is 32. So that's going to be X is equal to 72 grade 8s prefer volleyball. So, identify the unknown, make the comparison, make the proportion, solve it. Let's look at one more. A baseball player has a home run to strikeout ratio of 3 to 17. If she hits 33 home runs, how many times did she strike out? Well, the unknown here, how many times did she strike out? Let X equal strikeouts. Okay, we're comparing home runs to strikeouts. So, home run is being compared to strikeouts. The ratio of home runs to strikeouts is 3 to 17. So for every 3 home runs, she strikes out 17 times. This girl doesn't take a pitch. She's swinging away all the time. Okay, now it says if she hits 33 home runs, so 33 goes on top because home runs is on top. How many times did she strike out? Well, she struck out X times. That's what we're trying to find out. Now, to go from 3 to 33, we times by 11. So we'll have to do 17 times 11. Oh, here's a quick way to do that. 17 times 10. And 17 times 1. That's 170. That's 17. So that's 187. X is equal to 187 strikeouts. She struck out 187 times. So she's either hitting a home run or walking back to the dugout. That's proportional reasoning and solving problems with proportional reasoning. I hope that helps. That's all for now. Flexing Teacher Weber, out.